So let's see why these rules work. I'm not going to do every single one of them. Most of them work similar. So I'm just going to consider the rule for 2 because that's the one that we're probably most comfortable with. The rule for 2 says that we only care about the ones place, the 6 here. I don't care about the 3, the 5, and the 4. I only care about this last little ones place. So I'll look at why that is. So I'm going to consider 2 divides 3,546. I know it does work because it ends in an even number. To see why it works though, I'm going to write 3,546 in expanded form. So that's 3,000 plus 500 plus 40 plus 6. 3,546. I'm going to write this again, but using powers of 10. So that's 3 times 10 cubed because this is the thousands place. 3's in the thousands place. 5's in the hundreds place, so that's 10 squared. 4 is in the tens place, so that's 10 to the first. And then I have my 6 right here. The reason I did this is because if we have it written in expanded form, we can see that each of these other terms already is divisible by 2 because 2 divides 10. So I've got a 10 in all of these. So each of these place values is already divisible by 2. So the only one that matters is my last term here. So since it's a 6, 2 divides 6. If that had been a 7, then the number wouldn't have been divisible by 2. So that's the reason that these rules work. And if you look at the expanded form, that's how you prove all of these different rules. So now let's look at an example. So I've got a big number here. Sorry. I've got a big number here, 5,308,220. This is one whole big number, not lots of individual numbers. Sometimes people mess that up on the homework. You're going to see a ginormous number there. The commas are just separating so you know the place value. The rule for 2 says you just look at the last digit. So this is an even number. So this number is divisible by 2. So I'm going to say yes, and then I'm going to list a reason. So I'm going to say yes because it ends in 0. So I'm going to say yes and a reason. You're going to have to state the divisibility rule. You're going to be required to know the divisibility rule. For 3, I'm going to add up all the digits. So 5 plus 3 plus 0 plus 8 plus 2 plus 2 plus 0. So I'm going to add them all up, and that gives me a sum of 20. 3 doesn't divide 20. So 3 does not work. So I'm going to write no. That's because 3, this is my symbol for does not divide. It's a straight line with a bar, like a cross through it. So 3 doesn't divide the sum. For 4, I don't add. That's the biggest mistake. I just look at the tens in the ones place. So this one is yes because 4 divides 20. For 5, I look at my last number. Again, it's yes because it ends in 0. Or something to that effect. It doesn't have to be those exact words, but something similar to that. For 6, I have to see if it works for 2 and 3. So the answer here is no, because 3 doesn't divide the number. If 3 had worked, then it would have been yes. Right, we got a few more rules. So we've got 8, 9, and 10. The rule for 8 says you look at the last 3 digits. Again, don't add them. So 220. And 8's kind of a little tricky. Its rule doesn't work quite as well because we don't really know all the multiples of 8. But 8 does not divide 220. So no, because 8, here's that does not divide again, 220. 9 is the sum. I already know the sum was 20 from above, but I could add them all up. So no, because 9 doesn't divide that sum of 20. In this case, you could also say no because 3 didn't work. You just have to be careful. If 3 works, that doesn't mean 9's going to work. For instance, 3 divides 15, but 9 doesn't. But if 3 is no, then 9 has to be no. Just like if 4 is no, 8 has to be no. And 10 is going to be yes. That's because of that 0 again. So yes, because it ends in 0.